talk from the perspective of dissolved oxygen. So, for example, if we take up any water body, in any water body, so we can we expect presence of some organic matter? Okay, so there would be some, let's say, some organic matter would be present. Okay, just for representation purpose, I am just making in a segregated way. Okay, and there can be some, can there be any inorganic contaminants present in the water? Okay, inorganic contaminants, let's say for example any heavy metals like lead, chromium, or like such kind of heavy metals, arsenic, all such kind of things are nothing but inorganic matter. So try to keep it as like organic matter. And every water body will consist of a little amount of oxygen that is present in that one. So there we can expect presence of some oxygen. I'm just representing in this form. Okay, so there can be presence of oxygen in the water body. So whatever the amount of oxygen that is present, O2 present in water, that amount of oxygen that is present or contained in the water body is nothing but dissolved oxygen. Okay, so which is present inside that is dissolved oxygen. Okay, and as we are saying that there would be an organic matter present in that. Organic matter can be, let's say, any leaf, any litter, or there can be anything like, let's say, dead fishes or dead zooplanktons or such kind of things. Any living matter, that is nothing but organic matter. And over the course of time, what will happen? This organic matter would be decomposed with the help of microorganisms, isn't it? So there would be some decomposers. Decomposers will try to decompose this organic matter in the presence of oxygen. Okay, in the presence of oxygen, microorganisms will decompose the organic matter present in the soil, present in the water. So the amount of oxygen that is required for the process of decomposition of this organic matter, that is nothing but biological oxygen demand. Are you getting that? So that is nothing but biological oxygen demand. In very simple manner, that's how we can explain it. So biological oxygen demand is one of the important measure of the water pollution. So more BOD is directly proportional to the water pollution. Okay, so for example, if more the BOD, that means when more amount of pollutants are present in the water, more amount of oxygen is required for the decomposers to decompose it. So that's how it indicates that if more the BOD, it indicates more the pollution. Less the BOD, less would be the water pollution. So that is one thing. And here we are also talking about dissolved oxygen. So how dissolved oxygen will vary in its content. So that is also another thing that you have to learn. So we are saying that only organic matter. What? Yes. Obviously, when we are talking with respect to BOD is only concerned with the decomposition of organic matter. That means it indicates that more amount of organic matter is present in that. Okay, so it is obvious. It's an inference we can take likewise. So there, yes. It is a consequence of water pollution. Algal bloom indicates that there is water pollution. Okay, it's an indication. It's an effect, consequence. Okay, so now when we talk from the perspective of dissolved oxygen, so dissolved oxygen is usually, it is inversely proportional to temperature. inversely proportional to the temperature. That means more the temperature, less would be the dissolved oxygen. Okay, more the temperature, less would be the dissolved oxygen, and lesser the temperature, more would be the dissolved oxygen content. That means when water is very warm, when water is heated up, then obviously the amount of oxygen present in the water body will get reduced. That's why if you see in some of the places where the water is too hot, so then obviously living organisms cannot live, because one another unfavorable condition is that amount of oxygen that is present in the water will be vanished or will be reduced. So that is one another important thing. Okay, likewise you can remember. So this is the relationship between the dissolved oxygen as well as temperature. Okay, then now here we are saying that there would be organic matter also. Okay, so there would be organic matter also. So here how we will just can define COD. COD is another measure of water pollution, another measure of water pollution. So here what does the COD will do when we talk from the perspective of entire pollutants, both organic as well as inorganic matter. So here COD refers to the amount of O2, amount of oxygen required to decompose both organic and inorganic matter. That amount of oxygen that is required to decompose both organic and inorganic matter, that refers to chemical oxygen demand. Are you getting that? So only when we are talking with respect to organic matter, then the amount of oxygen is BOD. If we incorporate both organic matter as well as inorganic matter, so then the amount of oxygen that is required to decompose that particular thing is nothing but COD. Okay, now you have understood basically BOD and COD. Now we are saying that both of them are the measures of water pollution. Now looking at these observations, try to say which would be the better mode of water pollution measurement. Good, very good. It is COD, because here it incorporates both inorganic as well as organic matter. So comparatively, when we talk from the perspective of BOD and COD, COD is the better indicator of better measurement of water pollution. So that is one thing we have to keep in mind. So that is one aspect that you have to remember. Okay, so this is with respect to DO, BOD and COD.